All right, in this lab, this is the rates of reaction lab, and this is for the iodine clock reaction. And the indicator we're looking for is a positive test result between an iodine and a starch. And so in previous classes, like in biology, or maybe if you've taken a food science class, you've done iodine starch tests, and you get that blue-black color. And so we have a control on the left, and in each one, if you notice, it's all the way to the top. We have 10 milliliters of solution B in each of the cylinders, but in the right side, we have a varying degree, and then we're gonna add some water into each one. So we have a 10 milliliters, then we have 8, then we have 6, and then 4, and then finally 2. And what I'm gonna do is I'm gonna add in water into each of those, and then we will pour into the respective beakers. Once we pour into the respective beakers, I will add the two together, and what you need to do from your end while you're watching, as soon as the liquids contact instantly, as soon as you see that first drop contact, you want to start a timer on your phone or if you have a stopwatch, and as soon as you see the change in color, you're going to press stop again. So you're going to do start and stop. Start when you first see the liquid contact from, I'm going to pour from B into A, and then as soon as you see the color change, you're going to press stop. And what we should notice is that there should be some correlated value to try to determine what the effect of concentration is on rates of reaction. So I'm going to just set the phone down here and hope that it doesn't fall over. And we'll give ourselves some space. And so our first, I'm going to move these all back a little bit just so we have a little room and make sure we're doing things appropriately. And we're going to do one at a time. And so we have our 3 sets, and 4th and 5th, and then finally our first. So we're going to go in order from an equal value to another equal value. So we're going to go from 10 and 10, and then we'll go 10 to 8, 10 to 6, 10 to 4, 10 to 2. And again, each of those will also have an equivalent 10 milliliters, but I have to add extra water into them. So for example, the first one is already set, but the second one I have to add 2 milliliters of water into. Then I'm going to add 4 milliliters into the next one, so that adds up, 6 plus 4 equals 10, so on and so forth. So we're going to get our first two again. The first two already had 10 of each. Hopefully you can see that that's actually up to the 10. So I'm going to pour them into their respective beakers. We'll try to get as much as you can in. Obviously, you're not going to get everything in there. So again, as soon as you see this liquid make contact with the liquid in here, then you're going to press start on your stopwatch because you're going to record the data. Maybe there's a link down below for the lab, or maybe you have the paper copy already in your hands, or maybe it's a Google form, depending on how you're actually seeing this. But as soon as you see the liquid contact, press start. As soon as you see the color change, press stop. Okay, so notice how that went relatively quick. So I'm going to get those ones out of the way. And the second one, notice I don't have 10, I'm only up to 8. And so I'm going to add 2 milliliters of water to this. And so now we're up to the 10 mark. And so we will bring those beakers in closer. I have my 10 and 10 now. So now this is, for example, an 80% solution over here because it was 8 milliliters of the solution and then 2 milliliters of water. So again, as soon as the liquid contacts, as soon as you see the first drops hitting in there, press start. As soon as you see the color change, press stop. There you go for the second one. On to the third one. Again, I have my 10 mils, and in this one, there is only 6. So again, I'm gonna add up to 10. And obviously we wanna make sure that we're right there at 10. So again, we can see, hopefully there, it's right at the 10 line. So I'm going to add them into their respective containers. Move these out of the way. Then again, as soon as B hits into A, as soon as you see that liquid drop hit, start, and then when it changes color, stop. Notice it's starting to go a little slower, which is a good sign. We've reduced the amount of concentration. So if you think about effective collisions, if there's less material there to collide, then obviously there's less reactions that can take place. So again, I have 10, and now we are down to the 4. So I got to add 6 mils of water into this one. All right, we're up to the 10. I'm going to add both of those into their respective containers. And here we go. So get ready to press your start and your stop. Again, as soon as the liquid hits, start and then stop at the color change. There we go. And then finally, our last round, I only have 2 milliliters in there, and it's going to be 8 water. So this is a 20% solution on this side, where we started out again with 100, and then we went to 80, then to 60, then to 40, and now we're at 20. So we have one more trial to go here, and then you can answer your questions as appropriate. And again, 10 of each. There's my 10 of B, 10 of A. I'm going to pour those in there. Again, as soon as B hits A, you're going to start your timer and then stop it with the color change. Boom, and there we go. And notice with the smallest concentration, it took the longest time. So that again is the iodine clock reaction relating to rates of reaction and how that correlates with concentration. This one had the lowest concentration, and think about it actually took the longest time. Just by viewing it, hopefully you went through. If you need to go back and just forward to the spots. You can look at the timelines where the initial pour started and where the colors changed. So be sure to leave any comments below if you have any questions or concerns, and or if you're, depending on if you're in my class, if you're looking at the Google form or the sheet, make sure you fill out all of your data appropriately and answer any questions that are correlated. Thanks.